Hello everyone, welcome to Intermediate Metal Casting. I'm Rob Carter and I'm super excited to be spending this term learning about metal casting with you. I developed this course because metal casting is a very important manufacturing process in our country, and I wanted a better way to share some of the exciting industry opportunities there are for engineers, beyond what are covered in the introductory course here at Cal Poly. So in this video, I'll talk about why I think metal casting is important and discuss some of the technologies and processes that we'll explore in the course. So let's get started. So why is metal casting important? In the United States, over $100 billion of goods and services are produced in the manufacturing of metal castings each year. And of that, about $32 billion are in the form of salaries and benefits. Currently, nearly 500,000 people work in jobs that support the foundry industry. These are mostly jobs in non-technical support roles such as crane and forklift operators, process technicians, sales and equipment maintenance. So if you do the math, the average worker in the casting industry earns about $65,000 a year. Based on the Cal Poly engineering graduates who I know who've gone into the foundry industry, the average starting salary for casting engineers is about $80,000 a year. So now let's talk about where castings are found. The aerospace industry is a large user of complex, lightweight, high-performance castings for turbine engines, landing systems, and many other applications. Automobiles is another application of metal casting. Wheels, engine blocks, motor housings, and brake systems are just a few examples. A typical car has over 100 metal castings in it. How about the food processing industry? Baking, mixing, cooking, and fluid delivery systems all have metal castings throughout. How about sports and recreation equipment? It's another area where metal castings are used. Fishing reels, golf irons, and drivers, fitness and cycling equipment are just examples. The country's infrastructure. This includes buildings, roadways, flood control, and safety systems. All are built with multiple metal castings. They're right in the walls around you. How about the energy sector? This includes the generation of electricity by wind, hydroelectric power. These contain many large castings to keep the lights on everywhere. Where are metal castings found? Everywhere. It's said you're rarely more than 10 feet from a metal casting. So now let's discuss the technologies we'll explore in our course. First, we'll talk about casting design and the engineering drawings we use to communicate part manufacturing details and specifications. So we'll revisit your engineering drawings. We'll need to study gating design, which is critical for feeding liquid metal into the mold cavity in a fashion that fills completely and allows for metal shrinkage during solidification. The solidification process for metals is another area we'll explore. It's particularly interesting since metal transforms from a liquid to a crystalline solid progressively from the mold walls in at different rates in the casting. So clarity around this process will feed into good gating design strategies. Finally, we'll use flow and solidification simulation software to predict where problem areas may be in our gating design so we can make improvements before actually molding and casting. One last thing I want to share is some of the types of projects we'll work on in the lab. First, we'll make sand castings using a core to form the interior cavity. We'll use 3D printing to make patterns, form a mold around them, and then cast them in metal. And finally, we will design some smaller parts using 3D printing and make castings from them, and then larger parts using the shell investment process. Well, I hope you're getting excited about this course. I know we're going to learn a lot together, and we're going to have a lot of fun too. Bye for now.